Two and a Half Admins, episode 105. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. Brian Krebs wrote an interesting article recently, The Security Pros and Cons of Using Email Aliases. Now, this wasn't quite what I was expecting, because to me, an email alias is just a different address that ends up in the same box. But this turned out to be about adding a plus character, let's say, to your Gmail address when you sign up for a service. So instead of joeressington@gmail.com, it would be joeressington plus twitter@gmail.com. And that would still go to my normal email address. But in theory, if I use that plus character and then something unique for each service, then I'll know if that email address gets leaked and I get a bunch of spam to that or whatever, I'll know, okay, that came from a Twitter leak.
The problem is this relies on an interesting inversion of a common trope. What you're basically talking about here is introduced insecurity through lack of obscurity, because the spammers can parse that just as easily as you can. They have the same amount of information as your mail server does about how that's been tagged. They know which part of it is your actual email address. They know which part of it is the extra tag, and they know that if they just remove the tag, then it won't get handled like that, and it will just go into the main inbox unaffected by any rules that you've set up. So in order for, Joe Ressington plus Twitter@gmail.com to reliably indicate this email came from Twitter, you have to assume that Twitter doesn't know what the plus means in the most common email provider on the planet, last I checked, and that they're honorable enough, not to just take it on themselves to strip that out to bypass whatever you've done with that. And I think that's a pretty safe assumption for Twitter that they're not going to do that. But usually when you're using these kind of aliases, whether you're doing it, the Gmail way, where they've just made it available to the masses by add a plus into your own email address, or whether you do it like you and I would by setting up a completely separate email address that just gets routed into your main inbox later.
I do something similar with a catch-all, where basically any address except for ones that I've routed to a black hole at this domain will go to my inbox, and I can use Twitter at that domain. And then, they can't really remove that because they don't know what the actual name of the hidden inbox is in that case. Although it does get weird questions sometimes, like I think it was a local restaurant or something, and they're like, why do you have our restaurant name in your email address?
Back in the mid-2000s, I guess, when I was doing a lot of shopping at Best Buy, you're supposed to register an account with them, blah, 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 whatever. And obviously I used Best Buy at my domain name for the email address. Cashiers every time would give me this look like, oh God, corporate's here when I was checking out, and they would see that Best Buy at, because they just didn't really understand, the different side of the at sign means it's just whatever. Because to most people, you don't have any more control over the front than you do the back. You get whatever the ISP gave you and you have to live with it.
Yeah. Or your IT department at work or whatever. Yeah.
One of the things Krebs mentioned here was that a bunch of security-minded readers had actually alerted Krebs sometimes of, I got spammed to this specific alias, and that probably means that the company I gave this alias to had some kind of breach, and a lot of times that had actually turned out to be true. But like the person Krebs is interviewing here from Hold Security said, a lot of the threat groups have learned to just strip off plus and everything after it out of the email addresses so that it doesn't give that away as much.
And the odds are still pretty good that if you're getting spam and it's got, one of these alias tags on the end of it, that's a pretty good indicator that, yes, there was a breach at whoever you actually gave that tag to, because there's just not a whole lot of reason for an attacker to stick one of those on. If they scraped a bearer address, there's not a lot of reason for them to add a plus on the end of it. If it's not at Gmail, that's going to render it completely undeliverable, at a lot of services, for one thing. And for another, again, there's not a lot of reason for that. On the other hand, if you decided to buy GPUs from some kind of promising, but you'd never heard of them, parts vendor, and you literally registered with their company's name at yourdomain.com, and 3 months later you're getting a ton of spam to that, then yeah, they have a problem there. I've had arguments with exactly that scenario. I want to say it was like Giant Computing or something was reasonably well known for a brief period about 15 or 20 years ago. And I had exactly that. I started getting a lot of spam to the address that I had set up specifically for those, purchases. And when I tried to contact the company, I was talking to the owner of the company. He just got super vehement about there's no way anybody had breached his systems or he'd sold any addresses or whatever. And, I must have just used that address somewhere else and I didn't think about it. I'm like, dude, where else do you think I used the address your company at mydomainname.com? He thought about it for a while and he was like, I guess you're right. Crap. And I'm like, yeah, start thinking about what employees have access to that database and, which ones look like maybe they might sell that to a spammer for some extra money on the side, because it's probably what happened.
I saw a real feel-good story. Jared Mouch, who was the guy who was quoted $50,000 for Comcast to connect his home to broadband and decided that, no, he's going to start his own ISP. Well, that has been so successful that he managed to put in a bid and get a $2.6 million contract from the government to expand his ISP. This is all in rural Michigan. He is just an internet hero as far as I'm concerned.
I mean, this is the finest tradition of, you scratch your own itch. A dude had an itch and the ISPs refused to scratch it. So he not only scratched it, he scratched it so hard everybody else could get it in on it too.
Yeah. When he got started, there was about 30 rural homes that were running on his, and since grown it to 70. And yeah, with the money from the American Rescue Plan thing, their plan is to get 600 more people hooked up to it.
Yeah, and here in the United States, we do have government programs for expanding broadband rollout to underserved areas, and he lived in an underserved area, so that's why that grant was available.
What jumped out at me is that it's actually quite affordable, his service, and really, really quite decent.
It's $55 a month for 100 megabit with unlimited data.
Yeah, and like $80 a month for 1 gigabit symmetrical.
Yeah, both symmetrical. I mean, that is a great deal in the US, right?
So here's the thing about that. It is and it isn't. If you're talking about a major ISP, that's an incredible unheard of deal you'll probably never get. But whether it's, Jared Mouch or whether it's the local electrical cooperative, here in the Columbia, South Carolina area that started offering fiber broadband to everybody in its, power delivery service area, that's usually about the price you see. When you got municipal broadband or the power company decides to deliver it, or, you have some relatively small, very tech-focused startup like what we're talking about here, the prices all tend to coalesce around that same target. So in one sense, it's an incredible deal. In the other sense, it's like, no, once you cut the blood-sucking gigantic ISP that's also a content deliverer, that's also a content creator, that's also yada, 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 it's about what the price comes down to.
Yeah, well, and I think it's also partly, it's the price point that people are comfortable with, right? If it gets too much more than that, I'd rather have the slow internet. Well, not me personally. I still have to pay out the nose for it. Well, the one thing I did find interesting is he mentions that, some of the initial rural houses he did actually cost him like $30,000 to manage to reach. And so Comcast's quote of $50,000 wasn't just piss off. It was, no, it's actually going to cost some money to build out the network to where you are. But if you get enough houses, maybe it's worth it.
Or if you get government grants to
get over that hump, yeah.
I think probably, another part of why he's able to deliver that kind of service at that kind of price and that kind of quality is that he's the ISP version of, like a quote, full stack developer, unquote. He's not, he is subcontracting more and more things out as he grows. But to begin with, he pretty much did all the things, which means he's got a good understanding of all the things. It means that he actually bought the right equipment, like the type of drilling machine that can make a single entry point and then drill horizontally underground so you're not tearing a giant trench through people's yards. Well, there's nothing stopping Comcast or Spectrum or whoever from doing that. Part of the reason they're not bothering is because they're usually not bothering doing the to-the-door install at all. They're typically subcontracting that out to just some random jagoff with whatever they brought to the table. Maybe it's a ditch witch. Maybe it's a small cat. It's whatever they had, and they'll do whatever kind of a job they do with it. And they're not going to have invested a lot up front or have, come up with a really good set of standard procedures because they're just doing the thing to get the few bucks and leave.
Well, like I said, Jared Mouch is an internet hero, and we need more people like that in the world. Well done, sir.
Well done.
Okay, this episode is sponsored by Tailscale. Go to tailscale.com. Tailscale is a VPN service that makes the devices and applications you own accessible anywhere in the world, securely and effortlessly. It enables encrypted point-to-point connections using WireGuard, which means only devices on your private network can communicate with each other. Unlike traditional VPNs, which tunnel all network traffic through a central gateway server, Tailscale creates a peer-to-peer mesh network. It handles complex network configuration on your behalf, so you don't have to. Network connections between devices pierce through firewalls and routers as if they weren't there, so there's no need to manually configure port forwarding. Tailscale is available for Linux, Mac, Windows, Raspberry Pi and ARM, Android, iOS, Synology, and for devices that don't allow additional software to be installed, such as printers and other embedded devices, where you can set up a subnet router to act as a gateway, relaying traffic from your Tailscale network onto your physical subnet. So go to tailscale.com and try it for free on up to 20 devices. That's tailscale.com. I had a ton of people ask me for Jim and Alan's opinion of Linux After Dark episode 23. Now, I never turned down a chance to do a bit of cross-promotion, so I'll link to that episode in the show notes. The question on that episode was, in a world of cloud and serverless, is there any point in most people learning the command line? And we went on to clarify, beyond your basics, LS and rsync and CP and stuff like that, is there any point becoming really proficient with the command line? And the conclusion we came to was no. And people suspected that you two may disagree with that.
I would. I listened to that episode, and here's the thing. Most of what Gary and Dalton and the lads were saying, I don't necessarily disagree with it. The thing is, I think that it's only correct in a specific context. I think that the lads tend to be a good bit more developer-focused, and their takes on whether it makes sense to learn proper server CLI stuff these days, in quote, the era of, cloud and serverless and whatever, it all comes from a more developer-focused perspective. And I think the thing that they missed is that no matter which particular discipline of IT you focus in, you become the most valuable if you're at least somewhat competent in both the layer below it and the layer above it. And if you're a developer, that means that you're going to be the most valuable developer if you're relatively competent on the command line of a normal server, which is, a layer below, and also if you're competent at the cloud, the serverless. I hate that term. It's never true. But yeah, that environment. The reason that it makes you more valuable is both because you understand the automation at scale that allows you to more easily control how large of an audience your code can serve. That certainly explains, I'm good with the serverless stuff. Okay, great. So you understand automation for scale. But you also want to understand at least something of the individual box level of system administration, because if you don't understand that, you don't know how to tune that stack, you don't know how to evaluate that part of the stack, you're potentially leaving a lot of performance on the table, possibly introducing reliability problems. And also, no matter how prevalent these big quote serverless unquote stacks get, somebody still has to actually design them out of actual servers, running out of containers or VMs or what have you. And if you're that person who can do that, then that increases your value quite a bit. You don't have to necessarily specialize in that. Another thing is that I don't think you should be going into any IT field as a larval form with the idea that just, I want to be this. I want to be a developer. I want to be a sysadmin. I want to be a cloud architect. And that's what I'm going to learn to do, and that's all I'm going to do. No, you don't do that. And when they were talking about, how they would teach their children or whatever, well, this is also a subject near and dear to me. I've got 3 of my own, and my own approach is I want to show them all the things. I want them to get a tiny taste of all the things and see what they're interested in. Because as far as I'm concerned, if you're going into IT from this, top-down driven perspective of I'm going to do X because X is how I make the money and get the sweet job, you're going to suck. If you want to be really good in any IT discipline, you have to arrive there in large part because it's suited to you and you're suited to it. And the way you find that out is by experiencing a little bit of everything. Now, for example, when I grew up, sysadmins were barely even really a thing. There just wasn't that much code that, that you could adopt from other places and put together in interesting ways. By far, the majority of the jobs then, were dev jobs, and sysadmin was something that you did a little bit else on the side. But if you wanted to do something on a computer, you probably had to write the code to do it because there just wasn't that much of it out there freely and easily available in the 1970s and 1980s. So I thought I wanted to be, what they called devs back then, programmers. I wanted to be a computer programmer. Well, then as I get further along and I experience more things and I realize there's so much you can accomplish working with the code packages that are already out there and just deploying them in ways that, match the workflow of an organization or an individual or department or what have you, that very rapidly became of much greater interest to me. Other people exposed to both disciplines are going to go more on the dev side than I did. But in either case, if you really want to be valuable, you want to know a good bit about both sides. I'll tell anybody I'm far more of a sysadmin than a dev, but that doesn't mean I'm not a dev,
Yeah, my journey was kind of the same. When I first got started in high school, I was more interested in programming, but eventually I kind of found that programming, it was a creative process for me, and I had to be in the mood in order to do it. And I really didn't think I could sit and do that as like a 9 to 5. And when I did a work placement at the power plant and started playing with the sysadmin stuff, I found that, orchestrating a bunch of machines and making things happen was actually more fulfilling for me anyway. And so I did a long time of mostly being a sysadmin, and then slowly got, as, my interest in ZFS and wanting to extend it and do interesting things with it, got back towards, again, being more of a developer in the last couple of years than a sysadmin. But I think, like what Jim said, is being a well-rounded person instead of a very narrow, pointy person is definitely much better. And I think part of this argument can even go back to a similar argument we had decades ago about the difference between the command line and the GUI. And it turns out it's kind of the same argument in that whether it's a UI or the cloud, it's all just an abstraction around what the command line is doing. And if you understand what's happening underneath, I'm not saying don't use the GUI. The GUI can be faster and better, but you'll get more value out of the GUI if you understand the concept that the GUI is doing in the back end. Just like, if it's serverless, it's like, cloud is somebody else's computer and serverless is basically somebody else's server. It's almost the same thing. But if you understand how running your program will impact the server, you can actually see how it's going to perform in the serverless environment. And if you just have no concept of, if I do it this way in the program, it's going to use more resources, but I don't care because it's not my computer. It's like, well, you might care when the neighbor in the cloud is doing that, and now your serverless thing runs slower than it did yesterday because you're now with a noisy neighbor. And understanding what actually is involved in running a server, even if it's being done by somebody else. Suddenly it's not a sysadmin in your company a couple of cubicles over or whatever. It's somebody that works for one of these hyperscalers and they're doing the work for you. It doesn't mean the work doesn't get done.
Yeah. Another thing that I think the lads missed a bit, they did talk about how the serverless stuff is essentially an abstraction. And they framed the question as largely, is it worth learning the layer beneath the abstraction when you can just learn the abstraction? Like I already said, I think it's important to have, a smidgen of all the layers because you don't know what you're going to be good at and well suited to until you experience quite a bit. The other thing is that if you say, oh, well, I don't want to bother learning this low-level stuff, I'm just going to learn the abstraction, very quickly you get into situations where you had to learn just as much crap in that abstraction layer. It took just as much time to learn. It's just as complicated, in some cases more complicated than it would have been on the layer beneath. And you couldn't avoid it because those things were important. And you started out trying to make things easy and abstract them away, but then you get yourself into a position where actually you do need to work with those lower level things, and there's ways to deal with it in the abstraction layer. But now all you know is the abstraction layer. You spent just as much time learning that crap as you would have learning the actual layer where those things happen. And you don't know the more important thing, which is how those things are actually configured beneath your abstraction layer. This also leads into something that the lads did cover. Again, giving them credit, they did acknowledge that only learning these abstractions that frequently are implemented as, vendor specific can lead to you suffering from greater cases of vendor lock-in. Because, if you write your app around features or syntax or an API that only exists on AWS, then it's much harder to migrate to a different provider or maybe to your own local hardware or whatever. And all that is certainly true. This is not always a serverless thing. Another example that gets touched on is, when you're talking about using APIs to interact with a lower level service. For example, if you're a casual developer of database applications, you might only learn a generic SQL API that can be used to tie to a backend running on Microsoft SQL or MySQL or PostgreSQL. And you might feel that that's good enough. Well, I just learned that API and I don't care what the backend is because it's fine. Well, that works until you get to a point where there are very serious, real implications behind that backend, whether they be performance, or whether they be data correctness, whether they be weird edge cases that are cropping up in your real world use of that application, and now you have to deal with it. But all you know now is that API, and if that API was just as complex to learn as the backends were, to me, that starts feeling like a lot of really wasted effort. I get kind of hostile to the idea that I should spend an inordinate amount of time learning like weird quirks and abstractions in a high level API or abstraction when I could have accomplished the same things as easily or more easily sometimes in a lower layer.
Yeah, or just understanding at least the basics of the lower layer makes learning the abstraction that much easier, and understanding what it's abstracting and which complexity it's hiding from you so that you know what's going on under the covers.
And what potential configurations in that abstraction are liable to wedge the system because they hadn't really thought that part through. And if you don't understand the lower layer, it may not occur to you either. As long as I'm slagging on their bad takes, here's another one. They specifically brought up x86 processors as, sort of analogy. Like, so few people bother to learn much of anything about, the actual mechanics of, x86 architecture. There's not that many people working professionally as developers, even very highly paid, well-respected developers, who can just rattle off like all the registers in an Intel CPU or an AMD CPU. On the one hand, that's true. On the other hand, I don't think that's a useful comparison to, how things evolve in the ops versus DevOps world, because the vast majority of the x86 architecture has been backwards compatible and relatively unchanging for like 20 years. The level of churn in the ops versus DevOps world, I mean, it doesn't stay stable for 20 months, let alone 20 years. So banking everything on some particular API doing everything for you and remaining stable for a long time, it's just not a good plan.
Yeah, and we've seen the fact that the x86 APIs have tried to stay the same for so long and still get fast is how we get all these side channel attacks against them, because of all the shenanigans they're doing under the covers to try to make it fast while still appearing like an old-fashioned VAX CPU architecture from the 80s. The other thing I was going to say is specifically on their note about x86 there is, but every developer who understands kind of like, even on a high level, that the code they're writing is going to turn into these instructions and it's all just, add, copy, move in the end, is going to be able to understand what's happening to their program a lot better than someone that just thinks everything under that is some magic black box that I don't think about. And another one that they mentioned was, especially on the serverless or whatever, is like, then we don't need DevOps or ops people at all, and we just have the cloud provider, and they just provide the version of Python, and it'll run, and as long as you keep up to date to the latest version, it'll be fine. It's like, yeah, well, that's not always how it works, right? The cloud provider is going to randomly decide to go to some newer version, and now your code that was working fine needs a bunch of work to get brought up to this new version, or it doesn't work.
There's another analogy that popped up when I was quietly fuming in my car listening to that episode. So they talked about, the serverless thing is great because you can just write your code and not worry about the system. You don't care about the system. You just upload your code to the cloud and stuff makes go, and how great that is. And the thing that I'm thinking that whole time, I'm recalling, part of my own journey into professional IT in the mid to late 90s, starting out with like shared web hosting. Like you build some HTML and maybe a little bit of JavaScript if it's late enough in the 90s, on your own computer, and then you FTP that up to just like some directory on somebody else's Apache server, and yay, you have a website. And like, is that everything you need to be a good web developer? No, not even in the 1990s. You just so quickly get to the point where you're like, okay, well, this was fine for like, the page that my grandma and three of my buddies for high school, read like once every 3 weeks when they thought about it. But now I have something like interesting that gets a lot of traffic and has more dynamic features. And well, now I need to start thinking about like, how is the stack put together? What kind of resources does my server have? How can I extrapolate this more efficiently? You hit that rapidly. And Yes, there will be many things that can be done at many scales, not worrying about architecture and not worrying about the guts of any particular server, even when you call server just, a VM or a container. There's lots of things that that's sufficient for. There are lots more things that no, that's not going to cut it. And if you're the dev that only knows write node, upload node to serverless stack, that's going to cut you out of a lot of really interesting things, a lot of potentially high paid things, a lot of potentially prestigious things that you aren't competent to do.
Yeah.
So to wrap this up, again, I don't think that the lads were wrong. I do think their perspective was very developer focused, and maybe they missed a bit more on that than they thought they did.
Okay, this episode is sponsored by Linode. Go to linode.com/25A, support the show, and get $100 free credit. From their award-winning support, offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. And check out their managed MySQL, Postgres, and MongoDB databases that allow you to quickly deploy a new database and defer management tasks like configuration, managing high availability, disaster recovery, backups, and data replication. Simple and fast to deploy with secure access, their flexible plans include daily backups. So go to linode.com/25A, create a free account, and you get $100 in credit and support the show. That's linode.com/25A. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. You can learn more about that at 2.5admins.com/support. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your feedback or your questions for Jim and Alan, you can email show@2.5admins.com. So Josh writes, I recently acquired a bit of hardware from my job and have decided to make it a redundant firewall solution using either OpenSense or OpenWRT. Those are what I'm most familiar with. In my research, I also discovered that CARP would be the best solution, and OpenSense supports it pretty well. I only have one IP from my ISP, and I'm thinking of setting it up similar to this, and then he links to how to set up CARP from the OpenSense docs. Assuming I have hardware to set up any configuration, what do you recommend?
I would say the OpenSense with CARP. So CARP is the Common Address Redundancy Protocol. And basically what you would do is you'd have a shared IP address on the CARP between the two OpenSense machines. So they'd each have their own IP, which maybe wouldn't be routable to the internet or whatever. And then they would share the internet IP, and whichever one of them was elected as the leader would route the traffic for that. The big thing that CARP does is it includes a second protocol called PF-Sync, which is for the PF firewall that OpenSense uses. And it allows not only to sync the rules, but to sync the state between the two routers. So that, with NAT, every time you have a translation where you're connecting out to something, there's a bunch of state that lives on the router. And CARP will sync that state to the second one. So when it does fail over and switch to the second router, it's not going to interrupt connections that are already open because the state will exist on the second router as well.
As far as general advice for choosing between OpenSense and OpenWrt, usually OpenWrt is what you want if you want to flash a lower end consumer piece of hardware with something a little nicer. I have not been impressed with the x86 builds of OpenWrt when I've attempted to test them. I don't think they get anywhere near as much testing and, quality assurance as the ARM builds do. And in general, I just think the project itself tends to be tailored more to wringing as much performance as it can out of, frankly, kind of terrible hardware. So if that's something you need, you probably want OpenWrt. On the other hand, if you want a lot of complex, high-end features and a solid UI to, help you manage those more easily, that's more where OpenSense is going to shine.
Yeah, I think OpenWrt, sometimes you're constrained by the fact that, those consumer routers generally have only a couple megabytes of flash, like 16 or 32 or 64 megabytes of flash. And like you said, OpenWRT is about trying to cram as much functionality as you can in that small footprint, whereas OpenSense is more whatever old hardware you have laying around, and we can use that as a router. And so I think, especially for trying to do something redundant like that, that OpenSense will probably work better. But like Jim said, if you're trying to use existing like off-the-shelf routers rather than an old PC to do it, then OpenWRT might be the only way you can really get that into something you just flash on the hardware.
I'm surprised that you didn't say if you've got an x86 box, then just install regular Linux and learn IP tables.
You can do that. I don't think that's what most people are going to want. I don't think it's what our listener wanted. If somebody's asking, should I use OpenSense or OpenWrt to relatively easily put together a router, I don't think they want to learn how to build one from scratch.
Right, well, we better get out of here then. Remember, show@2.5admins.com is the email address to send in your questions for Jim and Alan or your feedback. You can find me on Twitter @JoeRessington.
You can find me @JRSSNet.
And I'm @Alan Jude.
We'll see you next week.